I'm going to talk you through the practical method to extract copper. Copper is found as copper oxide, which is an ore. I can extract the copper from its ore using carbon powder, and that works because the carbon is more reactive than the copper. To start with, this is a spatula, and in this tub I have copper extraction mix. So in here I have copper oxide pre-mixed with carbon, and I'm going to add a good 2 spatulas of the mixture into my test tube. I'm going to use these test tube holders to hold the test tube so that it's safe when I use the Bunsen burner. You heat the test tube in a Bunsen burner and you would have a roaring blue flame on. So you've got to imagine that that is a roaring blue flame, and I am pointing the test tube away from me so that anything that comes out does not spit in my direction. You keep on heating until you see a bright orange flash, and then you stop. You put the test tube on the heatproof mat to cool for a few minutes so that it is then safe to touch. Here's one I prepared earlier. So you would tip the contents of your test tube into the Petri dish, which is what we've got here. And what you should be able to see is copper, which is visible as red or brown flakes or lumps. And hopefully you can see that on the video. I can see it quite clearly from here. It is orangey, reddy brown, which tells me that I have then extracted the copper from its ore successfully using the carbon. Let's look at the word equation for what I've just done. So I took copper oxide and I added carbon. And because carbon is more reactive, I produced copper plus carbon dioxide. In a formula equation, that would be CuO plus C gives us copper plus CO2. And again, I can show my knowledge of oxidation and reduction. So the copper has lost its oxygen, so has been reduced. The carbon has gained an oxygen, so has been oxidized. And then that, as a balanced symbol equation, would be 2CuO plus C gives me 2Cu plus CO2. If you've forgotten how to do that, go back to the previous video where I'll explain step by step how to balance the equation. Now I'm going to show you how to extract iron, and it's a similar method but with some slight differences. This is a wooden splint. I'm going to dip it into water, and then I'm going to dip it into my extracting iron mix. So this is a mix of the iron oxide, which is an ore, and there is some sodium carbonate in there, but that's got a source of carbon. So the carbon will react with the iron oxide, which should allow me to extract the iron from the ore. I'm going to hold the splint. This here is a candle. It's a lit candle. I'm going to place the iron extraction mix into the candle and hold it there until all of the mixture is well burnt. So it's starting to blacken, and I'm going to have to wait until all of the iron has changed colour to show that the reaction has been completed. Okay, there we go, all black. What I'm going to do now is break off the burnt end of the splint, and I'm going to crush it with the end of the spatula. So what I hope to find is pure iron. Iron is magnetic, so what I can do, hopefully you can see this, I can use a magnet underneath, and you should be able to see that the iron, hang on, let me move my candle because I'm burning my fingers, that the iron is being attracted to the magnet, and I can pull it across the dish, which is proof that the iron has been extracted from the ore, because iron oxide is not magnetic, so I must have pure iron now because I can move it around the dish with my magnet.